Hello. So in this third video of the series, I want to talk about binomial approximation. Okay. So let me first write down the approximation and then I will try to discuss why this is true. So the binomial approximation says 1 plus x to the power n is approximately equal to, because it's an approximation, it is 1 plus nx, and this is only true if x is very small compared to 1. So this is only true if x is very small compared to 1. So let's look into this expansion. So you will say, okay, you have seen 1 plus x square, 1 plus x cube, 1. So what are all those numbers and why is this 1 plus nx? So first of all, I want to talk about the binomial tree. So this you will learn in the chapter Binomial Theorem of your maths course. So binomial theorem. So what I want to do is I want to start with writing these numbers 1 1. Then I will carry this number here and I will add these two numbers here. I will get 2 and I will get 1. And if I carry this 1 here, if I add these two, I get 3. And if I add these two, I get 3. And if I carry it, I get 1. So I carry 1 and I get 4 and I get 6 and I get 4 and I get 1. Okay. So the question is what are all these numbers and why am I talking about these numbers? So as you can see, these numbers 1 2 1 1 3 3 1 1 4 6 4 1, which are just I formed this 3 by adding these 1 and 2, and I formed this 6 by adding 3 and 3. So arrow goes like this. So these numbers you have seen in the expansion of x plus y. So for example, x plus y की power 1 is just x plus y. So here the coefficients are 1 and 1. X plus y whole square, it is x square plus 2xy plus y square. Here what we are doing, we are decreasing the power of x one by one and increasing the power of y. And you have seen this, x plus y whole square is x square plus 2xy plus y square in your previous classes. X plus y whole cube will become x cube. Then the next number is 3 and the power of x decreases to x square and y increases. Then power of x decreases and power of y increases, and then y cube. And we can also say 1 plus x की power 4 क्या होगा, so या फिर x plus y की power 4, so which you might have not seen in 10th, but you can say now it will be x की power 4, that is 1 times x की power 4 plus 4 times x cube y plus 6 times x square y square, just decreasing the power of x and increasing the power of y, and 4 xy cube plus y power 4, because 1 times y power 4. Okay, so maybe I can write it here. So with this idea in mind कि this can be expansion or this is a binomial tree कि हम ऐसे expansion निकाल सकते हैं, I want to write what will be the expansion of 1 plus x to the power n. Okay, so it will be 1 to the power या फिर 1 plus x whole cube, correct? 1 plus x whole cube will be 1 cube plus 3 times 1 square into x, so 3x plus 3x square plus x cube. No surprises about that. You have seen this expansion in your class 10th also, 9th also. But let's say if x is very small compared to 1. For example, I want to find cube of 1.03 या फिर 1.01 whole cube. Okay, either I can do is multiply 1.01 with itself 3 times. So in that case, I will get the answer, exact answer, to be 1.030301. This is the exact answer. And I can multiply 1.01 with 1.01 and 1.01 three times, or I can do this way. I can open this bracket. Okay. 1 plus 0.01 whole cube, and I will get 1. With this expansion, I can say 1 plus 3 times 0.01 plus 3 times 0.01 whole square plus 0.01 whole cube, and this is 1 plus 0.03 plus 0.0000. Okay, there will be only three zeros and then a 3, and plus 0.123456 and then a 1, and which is that answer, which comes out to be 1.030301. Same answer. Either I multiplied 3 times or I used the expansion. They are the exact answers. But let's see. As you can see, the third and the fourth term are very, very small, and that is because 0.01 whole square was very, very small. It was 0.0001, and 0.1 whole cube was even further smaller. So what is this approximation is trying to say is you can neglect these terms. You can neglect these terms because let's write it down here. So if x is very small, then x square, x cube and all those higher terms are much smaller. So I can neglect them. So for in this case, for example, 1 plus x whole cube can be approximated as 1 plus 3x, because I can say this is approximately 0, this is approximately 0, and in this approximation I should be able to guess the answer ki 1 plus 1.01 whole cube is same as 1 plus 0.01 whole cube, and this number is very, very small compared to 1. So I can say the answer is 1 plus 3 times. So it is the binomial approximation is 1 plus x to the power n is approximately equal to 1 plus nx. So because let's say first let's write it down, 1 plus 3.001, and that is 1.03. Okay, that's a very good answer given that the exact answer was 1.030301. So this was negligible, right? This is this is not even 1% of the difference. So we got the. So if you had an options in your for some question in question, so the options can differ like this: 1.03, yeah, for 1.07. So in these cases, this will be the answer, right? So hopefully it resolves that. But now let's talk about why it is 1 plus nx. So in all of the expansions we should see 1 plus x square. So it is 1 plus 2x plus x square. So this is the term that is neglected, right? So it is 1 plus 2x. 1 plus x cube. It is 1 plus 3x plus x square plus 3x square plus x cube. So these two terms are what we are neglecting. These are very, very small. So this is 1 plus 3x, right? And we just saw 1 plus x की power 4 में क्या coefficients आएंगे? That will be 4x, then 6x square plus 4x cube plus x की power 4, and ये x की power 4, x cube, x square. These are very, very small numbers as x is very small. So we have answer is 1 plus 4x. So after all this, hopefully this binomial approximation is okay with you. 1 plus x to the power n is approximately equal to 1 plus nx. This only works if x is very, very small compared to this number, that is 1. So let's do a certain examples here. Let's do a certain examples here to find their values also. For example, it doesn't only find these answers, it also finds these answers. For example, I can find 28 ki power 1/3 without even using a calculator. Okay, so for that या फिर I can calculate maybe a easier one, maybe let's say 8 की power half. Okay, so square root of 8. Well, everyone say okay, I can calculate that. I can so it says 2 into 2 into 2, and it was 2 root 2, and everyone knows what is root 2. It is 1.41, and it is 2.82 approximately. Okay, and that is because we knew root 2. अगर हमें root 2 नहीं पता होता, then it will be हमें root 2 पूरा निकालना पड़ता. We can use binomial expansion expression also for calculation of these. Let's see how can we get the approximate values using binomial approximation. So it will also work for cube roots or seventh roots. So first of all, we need to think about a perfect square that is nearby 8. Okay. Well, I can see one. There is 9. So I want to write 8 as 9 minus 1 की power half, because I'm thinking about a perfect square. So 9 is a perfect square. It is a perfect square of 3. So what I need to do in our expansion, there was a 1 here, but we have a 9 here. So what we will do, we will take 9 common from this bracket. So I have 9 की power half outside, and I have 1 minus 1 by 9 to the power half, and 9 की power half is 3. So it is 1 minus 1 by 9 to the power half. Okay, so now this is valid because this minus 1 by 9 is very small compared to this 1. 1 by 9 is very small. It is approximately 10%. So I will say answer is 1. So I will say this bracket can be approximated as 1 plus nx. So answer is 1 plus, let's say, half into minus 1 by 9, right? 1 plus nx, and that is equal to 3 times 1 minus 1 by 80. That is approximately equal to 3 into 17 by 80 approximately. So I'm saying approximately, and that is 51 by 18. So let's calculate 51 by 18. So which is approximately equal to 2.83, and 3 goes on. Okay, 3 bar. So 2.833, and which is very near to 2.81. Okay, so I was able to approximate the value of root 8 using the binomial approximation. So last example for this will be 28 की power 1/3. So anybody wants to, so you can think, right? You can think about a perfect cube, because we are taking a cube root. We have what is a perfect cube nearby 28? It's 27, right? 27 plus 1 to the power 1/3. So what I need to do is take 27 common, 27 to the 1/3 outside, 1 plus 1 by 27 to the power 1/3. And this answer I cannot calculate by hand. I can say answer will be 3.01 or 3.02, right? Because 3 ka cube is exactly 27. So iska cube root should be approximately 3.01. But what will be exactly, right? But it will be exactly. So to do that, we can use binomial approximation, and we should be able to get a good answer from all the 4 options that are available to you. And now I can use the binomial approximation, because this 1 by 27 is very small compared to 1. So I can say this is 3 into 1 plus 1 by 3 n times x. Okay. And that is 3. 1 plus 1 by 81. And that is 3. 82 by 81. And that is 246 by 81. And the approximate value for that, you have to calculate it by hand, but you can do the long division. So I will use a calculator here to save some time in this video. So 256 by 81 divided by 8. So 246 by 81, I'm sorry, is 3.037. Okay, and goes on. So I should be able to, I'm able to calculate the answer to some digits here. So I want to use a calculator to find the direct value of this. Is my answer correct? Is this approximation even correct? It should be, because this number was fairly smaller compared to 1. So हमारा answer correct होना चाहिए. So we can use a calculator, a scientific calculator, to find maybe 28 raised to the power 1/3. So we have the answer to be 3.03658. And so 3, 6, 5, 8. So 3, 6, 6. So we have the exact answer to be 3.03658. So 366. Okay. So which is very very close to 0 which is approximately equal to 3.037. So we have got this answer with binomial approximation without even knowing what is the cube root of 28, and the calculator says this is the answer. Hopefully you enjoyed this video and the binomial approximation is clear to you. Please look into the binomial tree also, because that will be again repeated in the chapter binomial theorem.